Hello and welcome back to Introduction to Windows Server 2012 and 2016 Administration. My name is Scott Neal, and this series is dedicated to teaching you the ins and outs of server admin for Windows systems, for particularly 2012 and 2016 server systems. We are in the process, if you've been following along, we've been in the process of building our domain controller. We built our domain controller in the last episode. We're going to be using Active Directory to manage our fishy chicky canaries resources on the domain. We're going to be, over the next few episodes, showing you how to build out Active Directory, add users, groups, organizational units, group policies, and then we're going to be rolling all that around and showing you how to manage resources, creating a file server, and so on. But today I really wanted to focus on domain controllers. Now that we have a domain controller built, probably a good idea for us to understand a little bit about how they work. We're going to finish covering exam objective 5.1 today, which is really lesson 13 if you're following along in our book. We're going to be talking a little bit today about how domain controllers work, some of the roles that they have. We'll outline those roles today. We'll talk about read-only domain controllers and when to use them. We'll look at functional levels, and we'll talk a little about replication today. We'll scratch the surface. We'll basically give you a description of what LDAP is. And before we talk about it later on in the series, we'll talk a little bit about DNS being as important as it is for domains. We ought to introduce you to DCDiag, the command line utility that we can run it and give us a cursory update and summary of a test of how DNS is implemented on the network. And last but not least, before we leave today, we'll talk about some security concerns when virtualizing domain controllers, as well as things to worry about if we're going to be removing or decommissioning domain controllers before we finish the segment. So by now you're probably aware of the fact that Active Directory services are going to be implemented using network's domain controllers, and that each domain controller is responsible for hosting one domain. It's going to store all the domain's objects in a database on that particular server. Users and computers that are members of a domain are going to be then for having to connect to that domain controller quite frequently as they authenticate to the network and start having to look for resources on the domain. It's going to poll the domain controller quite often for that information. So if you're following along with Microsoft protocol, Microsoft says you should have at least 2 domain controllers to ensure the Active Directory database is available to clients at all times. This is certainly true if you're running a mid to large size organization. Then you're going to have multiple domain controllers on your network, and the larger the organization is and the more spread out your resources are globally or geographically, the more important it is to have multiple domain controllers. So as we talk about domain controllers, there are different roles associated with domain controllers. Probably one of the biggest and most important roles is the global catalog service. And so every domain controller stores objects for the domain for which it was installed for. However, if I create a global catalog server, it's going to also store a database with all of the objects, not only for the domain it serves, but for the entire forest. And for objects that the global catalog service is authoritative for, basically the domain it was installed for, then it's going to store and maintain a full writable replica of the objects for that domain. For objects that the global catalog service is not authoritative, then it's only going to store an index of basically a read-only set of attributes for each object in the rest of the forest. The main purpose behind setting up a global catalog server is to reduce the network bandwidth and to improve the efficiency on the domain. So resources on the domain are going to be trying to locate other resources on the domain, and without global catalog servers, they're going to have to reach out and touch multiple servers to find the correct server that's responsible for maintaining and pointing to the resources as it manages. But having a global catalog server which indexes all of these resources, then I am not going to have to go out with my resources and touch each of these servers. I can just find a global catalog server. It will point me to the appropriate resource. This is going to, over time, save a lot of network bandwidth. By default, of course, the first domain controller in a forest is going to be created as a global catalog server. Thereafter, if I need additional global catalog servers on the domain, I can create them wherever they're needed. There are additional roles that have to be considered on domain controllers. Most of these roles are called master roles, and we'll talk a little bit about some of those today. There are basically 5 additional roles that are associated with domain controllers. The schema master, which is responsible for controlling all of the updates to the schema within a forest. The domain naming master is responsible for controlling additions and removal of domains in a forest. The relative identifier or RID master is responsible for allocating sequences of relative IDs to each domain controller in a specific domain. The primary domain controller emulator, also known as the PDC, is really served as an NT4 companion primary controller, so that if I have devices on the network that are not Windows 2000 or compliant, then the PDC will help rectify and control those devices. Last but not least, the infrastructure master is assigned to update user and group memberships, and it will then begin the process of replicating those changes to other domain controllers on the domain. Operations masters are really going to only be assigned one role per domain or forest. So DCs that hold operations masters roles are there to ensure a consistent and stable Active Directory database. Only one operations master role can exist in the forest for schema masters and domain naming masters. And only one operations master's role can exist for each domain in the forest for your primary domain controller, your infrastructure master, and your relative ID master. Read-only domain controllers is yet another type of domain controller that you may hear about. Read-only domain controllers, or RODCs, can only support incoming replication traffic. In other words, changes to the Active Directory database cannot originate on that domain controller. RODCs are not going to therefore allow you to create, modify, or delete Active Directory objects from that location. They're great for areas with minimal security or security risks, branch offices, for instance, or satellite locations. And it's also good to know that administrators working with RODCs in those locations do not need to have modified access to the Active Directory tree. Another term you may hear about when talking about domain controllers is the domain controller or your domain's functional level. Functional levels are really designed to provide backwards compatibility in Active Directory environments where domain controllers are going to be running various versions of the Windows Server operating system. For instance, if I have an old domain that's been sitting around for several years, I may have a Windows Server 2003 running a domain controller, some 2008 domain controllers, some 2012 domain controllers, and I may have recently even implemented a Server 2016 domain controller. Each one of those domain controllers, as we move up the Windows chain, provides additional functionality and features. However, I can only use the functional level representing the oldest version of Windows running on the domain. I'll have to disable all of those new features so that these domain controllers can interoperate properly on the domain. That's one reason why it's very nice to go ahead and start decommissioning domain controllers as newer domain controllers go online. The sooner you rid yourself of these older Windows versions of domain controllers, the sooner you can start taking advantage of the newer features that are available in the new domain controllers. Upgrading functional levels, by the way, is an irreversible process, so you want to be sure to decommission all of the servers representing the lowest servers in the domain before you upgrade to the next functional level. One of the primary responsibilities for any domain controller is the concept of replication. Replication is there really for redundancy. Microsoft therefore suggests, of course, running 2 or more domain controllers on a domain and making sure that they are replicating in a timely manner. It is imperative that each domain controller has the database that's going to be identical to all the other domain controllers in the network. So we use replication to ensure this identical database structure. Replication really is the synchronization process domain controllers use to ensure that their database information is up to date on all of the domain controllers. And there is a latency period, We call that replication latency, which is really the period of time for an update that occurs on an originating domain controller to propagate to all of the other remaining relevant DCs on the network. Sometimes this replication latency may take up to 15 minutes. However, security changes, things like disabling accounts or disabling computer accounts, are labeled urgent and begin replicating immediately on the network. And whenever all of the domain controllers are up to date, we call that a state of convergence. That is the state where no new updates are currently needed to be replicated on the network. There are different types of replication processes. One of the oldest types of replication processes is the single master replication. It is a process where a single primary system, the PDC, replicates the contents of its database as it changes to one or more secondary systems, also known as backup domain controllers on the network. Multiple master replication is where we have peers on the network, and it's possible to make changes to domain objects on any of those domain controllers, which then replicates all those changes to all the other domain controllers on the network. It's also a good point to tell you that those domain controllers in a multiple master replication do not need to talk to all the other domain controllers on that network. Really what happens is when I put a domain controller on the network in a multiple master replication environment, that domain controller is going to want to reach out and connect to the first 3 domain controllers it comes into contact with. Those other domain controllers thereby are also connecting to 3 other domain controllers, and so we end up with a really an arbitrary connection network between domain controllers. This provides redundancy and over time will help reduce the network bandwidth. Last but not least, another replication process is pool replication. Domain controllers with pool replication will then pull changes down rather than push changes out that may not be needed to all the other domain controllers. Therefore, one domain controller will decide that it talks to another and says, what do you have? Oh, I need that, and it will pull those replications down. So there are additional replication styles out there, but here are 3 of the more common replication styles you may run into as a domain admin. Now, if I want to give you a visual interpretation of single master versus double master, if I look on the left-hand side, multi-master replication really truly is a peer-to-peer process. All of these domain controllers really do talk back and forth to each other to help replicate data on the network. While a single master replication is really all about a PDC making a change to a PDC and then having that change propagate to your backup domain controllers on the network. From time to time, replication conflicts do occur on the network. Therefore, Active Directory does maintain a stamp that contains the version number, a special timestamp, and a server globally unique identifier that are created anytime an object originates as an update on a server. Conflicts are then resolved by comparing those attribute values. The object with the highest value by default is then replicated to the remainder of the network. The timestamp is used only as a resolution in case the attribute number cannot be used to achieve a conflict resolution. The following protocols and services must be present for replication to occur. DNS. DNS, of course, is required so that domain controllers can correctly resolve DNS names and replication partners. The remote procedure call, that's used to transfer updates between replication partners. Kerberos, of course, is an authentication protocol for both authentication and encryption, and it's required for all Active Directory RPC replication. And LDAP, the protocol is used to move an entire replica of an Active Directory domain. For instance, if I install a new domain controller on an existing domain. So, while we're on the topic of LDAP, what is LDAP? Well, Lightweight Directory Access Protocol is what LDAP stands for. It really is an open, vendor-neutral, industry-standard application protocol that's really for accessing and maintaining distributed directory information services over an IP-based network. It has become a standard communications protocol that many directory service products, including Active Directory, use. There are lots of applications out there, client-server applications now, that will allow you to authenticate using LDAP and tailor the application so that users using LDAP can have certain levels of access to those applications. Common use for LDAP is to provide a central place to store usernames and passwords to facilitate that authentication. And each entry has a set of attributes and a unique identifier which is known as its distinguished name, or DN. A typical LDAP entry therefore would look something like this, with a DN of John Doe for that would be the person's name. The domain would be the example domain, and the suffix for the domain would be com. So for that, this would be a typical LDAP entry for John Doe. There's also another concept to be aware of, and that's sites. Active Directory uses sites to identify all of the well-connected computers in an organization, and that helps optimize network bandwidth. A site really is therefore a collection of subnets that have good connectivity. Generally speaking, that means that the site is going to consist of all the local networks for a specific geographical location, and a different site would be a network on a remote WAN location, maybe something on the other end of a T1 network or slower WAN technology. Site divisions are really going to be independent of domain tree and forest divisions. I have the ability to have multiple sites that are part of a single domain, or I can have separate domains, trees, or forests for any particular site. And the primary reason for creating sites on an Active Directory network is to control the amount of traffic passing over relatively slow and expensive WAN links between locations. So we have a site topology, and that consists of 3 Active Directory object types. Of course, we talked about sites. A site object represents that group of subnets in a single location, all having good connectivity. A subnet is an object that represents an IP network for a particular site, and site links are going to be responsible for connecting 2 sites together. And replication between sites, therefore, will have to be manually configured. Once the site topology is in place, then I can decide where to put my domain controllers and how often I want my bridgehead servers, those are those servers that provide those site links between WANs, to connect and disseminate information. There are times when I may need to troubleshoot my DNS service records for registration failures. As I said before, the domain name system is going to be essential for operating Active Directory domain services. A special DNS resource record, which is also known as a service record, was created at the time the domain was created and enables clients to locate domain controllers and other vital Active Directory services. So if we are curious about whether DNS is working correctly in our domain, one of the things that we can do is run the dcdiag command at the command line to confirm that the domain controller has been registered in the DNS. And if I run the dcdiag command, just dcdiag with no options, I will get a printout that looks like this. As you can see, this is not all of it, mind you, but there are a significant number of tests that the dcdiag will run by default. We'll do a how-to segment a little later on in the series that will go into dcdiag a little more in depth. Before we go, I do want to talk about virtualizing domain controllers. As I said, we do have a virtualization series as well, and one of the things you may start thinking about virtualizing is your domain controller. There are some special considerations for security that you need to think about before you decide to virtualize your controllers. First of all, administrators of member systems hosting writable domain controller VMs are going to have the same access as a domain administrator. And administrators of member systems hosting a read-only domain controller as a VM are going to have the same access as a local administrator on the DC. But because the DC VM has administrative rights to the member host, all virtual machines are potentially at risk for being compromised if the DC virtual machine gets compromised. And an RODC VM could theoretically send policies to a host system, including startup scripts, that could potentially compromise the host and therefore compromise the remaining virtual machines. Last but not least, before we go, removing a domain controller. Domain controllers serve a critical role in the domain infrastructure, and as we talked about before, domain controllers may have special master roles that only reside on one domain controller in the domain or even the forest. Therefore, removing a domain controller from our domain is not as simple as unplugging it from a wall. To remove a domain controller from the Active Directory system, I'm going to have to begin by running the Remove Roles and Features wizard. And I'm going to select Demote this domain controller as an option. I will also have to make some decisions about migrating any operations master's roles, which may be on the domain controller as well, to other domain controllers that are going to be residing on the domain. Alright, well, let's summarize. Domain controllers utilize a series of databases to manage Active Directory resources, and by default, all of those domain controllers will exist on the first domain controller in the forest. However, operations master's roles can then be migrated to other DCs as necessary and as the domain or forest grows. There are several replication strategies I can use as a domain administrator. Single master and multi-master and push replication are three strategies that can be used to reduce latency and help ensure convergence among all the domain controllers in the forest. Raising the functional level of a domain adds a new Active Directory features and improvements, but should only be done once I have removed lower domain controllers or lower Windows domain controllers from my network. I can then upgrade to the next functional level, to the next lowest server that may be running as the domain controller on the network. LDAP is an open, vendor-neutral, standardized application protocol for accessing and maintaining distributed directory information services, identifying objects by their distinguished name, and we'll talk about LDAP later in the series. Global Catalog. This is really an index of all the Active Directory objects, not only in the domain for which that domain controller serves, but also indexes all of the objects within the entire forest and prevents systems from having to perform searches among multiple domain controllers. And the domain name system is going to be essential for operating Active Directory domain systems. To accommodate directory services such as Active Directory services, a special DNS resource record is created and can be tested using the dcdiag testing command in command line as a test. Alright, that's all I got for today. When we come back, we're going to talk about using users in our Active Directory. We're going to look at local users, domain users, and talk about users in general as we move forward in the Active Directory piece of our series. So I look forward to seeing you then. Have a great day.